EV enthusiasts, beware. The most expensive brick on the block, Tesla shares, are lower ahead of the company's latest developments. Meanwhile, GM has just announced their all-new zero-emission engine that will make both electric and internal combustion vehicles obsolete. This radical new technology is said to be the next revolution in the automotive world, driving us toward a completely eco-friendly future of cars. So, let's not waste any time and check out this groundbreaking innovation as GM's CEO announces a new engine that will change the world. What exactly is this all-new technology? GM has been searching for an alternative to EVs for years now, and their search has led them to the all-new compressed air technology. Compressed air was initially explored in the 19th century, mostly for mine locomotives and trams in European cities, most notably Paris. However, the technology was abandoned in favor of internal combustion engines due to their superior power. In the early 2010s, the French car manufacturer Peugeot saw potential in combining compressed air with internal combustion engines, creating a hybrid technology that retained the eco-friendliness of hybrids without needing a battery. Although these prototypes never moved beyond the testing stage, they sparked interest in the automotive industry, especially GM. Recognizing the potential of compressed air vehicles, GM understood that the technology needed significant development to compete with internal combustion engines and the rise of EVs. As a result, GM began parallel research into compressed air technology alongside their work on EVs and traditional vehicles. How do compressed air vehicles function? Compressed air vehicles function very differently from regular engines and EVs. Instead of a conventional piston-driven engine or an electric motor, compressed air vehicles utilize pneumatic engines, also known as compressed air engines. Mechanically, these engines are similar to internal combustion engines using pistons like petrol-powered ones. However, instead of relying on an explosion for piston motion, pneumatic motors introduce air into a chamber, increasing pressure and pushing the piston outward. The air is then released, and a connected spring pulls the piston back, completing the cycle. Since the overall design closely resembles internal combustion engines, GM saw an opportunity to develop this technology rapidly using existing technical knowledge. What are the benefits of compressed air over EVs and internal combustion vehicles? One of the biggest advantages of compressed air engines is that they are 100% pollution-free. They only use pressurized air, meaning no environmental damage is done while the engine operates. Compressed air technology also outperforms EVs in some aspects. Unlike batteries or electric motors, compressed air engines don't require rare earth materials, making them significantly cheaper and more sustainable. Furthermore, generating electricity for EVs often relies on fossil fuels, reducing their true eco-friendliness. Another key benefit is cost efficiency. Compressed air engines operate under lower pressures than gasoline or diesel engines, reducing the need for heavy-duty materials. This makes them cheaper to manufacture and more environmentally friendly when produced at scale. Additionally, operating costs are virtually unrivaled. Compressed air is far cheaper than fuel or electricity and widely available. These engines are also 100% future-proof as they do not waste resources. Pressurized air remains structurally unchanged after exiting the chamber. Are there any drawbacks to this technology? Unfortunately, compressed air engines have several major drawbacks that have hindered their widespread adoption. Lack of power. Pressurized air has a very low energy density, meaning these engines are significantly underpowered. The torque output is extremely weak, making them impractical for many real-world applications. These engines must operate at high RPMs, leading to excessive component wear due to their mechanical nature. Lubrication is difficult since they don't use liquid fuels, leading to increased friction and maintenance issues. Most prototype compressed air vehicles have a range of only 140 kilometers, which is less than 100 miles, requiring frequent refueling. Many prototypes store pressurized air in steel tanks, making them heavy and susceptible to explosions if damaged. Despite these challenges, GM has been working tirelessly to improve compressed air technology, and they have achieved significant breakthroughs. Scene 2. Increased power. Increased power. New high-pressure air tanks increase cylinder pressure, bringing performance closer to gasoline engines. GM has developed chassis-integrated air reservoirs, using fiber-reinforced thermoplastics to improve safety and reduce weight. Improved safety. Unlike conventional air tanks, these new reservoirs won't explode upon impact, making compressed air vehicles safer. When will this technology be implemented? The answer is complex, but there is a strong possibility that compressed air engines could enter mass production within the next few years. GM has heavily invested in making this technology a reality. The mechanical similarity to combustion engines allows GM to develop these vehicles faster than building EVs from scratch. That said, GM isn't doing this out of pure environmental concern. They recognize that internal combustion engines are on their way out, and they lack dominance in the EV market. By developing compressed air engines, GM hopes to create an entirely new market and position itself as a leader in the next automotive era. The past attempts at compressed air vehicles. This isn't the first time a major manufacturer has attempted to implement compressed air technology. Peugeot, about a decade ago, developed a hybrid compressed air vehicle, combining an internal combustion engine with compressed air storage. This Peugeot 2008 Hybrid Air achieved an astonishing 120 miles per gallon. Yet, despite its success, Peugeot abandoned the project, citing a lack of profitability, a reason that seems questionable. The shadow of big oil. Some speculate that big oil companies may have pressured Peugeot into dropping the project, fearing that widespread adoption of compressed air engines could disrupt their profits. This theory gains traction when considering the mysterious case of Stanley Meyer, the inventor of the water fuel cell, in the 1990s. Meyer claimed to have developed a water-powered engine, but he was pressured by oil companies to abandon it. On March 20, 1998, after meeting with two Belgian investors, he ran out of a restaurant screaming that he had been poisoned. He collapsed and died shortly after. Strangely, his water-powered car and prototypes disappeared from his garage following his death. So GM, if you are listening, develop this technology in absolute secrecy. Otherwise it may suffer the same fate as Peugeot's hybrid or worse, Stanley Meyer's water fuel cell.